So here the question has two clues, very important. One is 3-day severe history of vomiting, which is loss of HCl. Second is on examination hemodynamically unstable and shows signs of poor tissue perfusion, which is nothing but shock. Until you see these clues, you cannot go ahead. All these values look normal until you calculate the anion gap, which is nothing but sodium minus chloride plus bicarbonate. So if you calculate this, you will get around 140 minus 86 plus 24, which is equal to somewhere 30. Okay, it is around 30 milliequivalents per liter. It is around milliequivalents per liter. So this is good. If you go ahead and calculate, so if you see this, it is nothing but HAGMA, high anion gap metabolic acidosis. So you established one component. You have metabolic acidosis, which is very high anion gap. If you want to know the second component, if it is compensated or anything, in this case you should calculate the delta ratio, okay, which is nothing but delta gap is equal to calculated anion gap minus normal anion gap. Okay, calculated anion gap minus normal anion gap. Calculated is 30, normal is around 12 if you take an average, that is nothing but 18. So this is the delta anion gap. Got it? And expected bicarbonate is equal to normal bicarbonate minus delta anion gap. Okay, delta gap, that is nothing but expected HCO3 bicarbonate is equal to 18 minus 6 milliequivalents, sorry, 24 minus 18 is equal to 6 milliequivalents per. I calculated it in mind and I was doing something. So 24 minus 18 is equal to 6 milliequivalents. So what is this delta ratio? It compares this delta ratio. It compares change in anion gap to change in bicarbonate gap. Okay. So if it were pure HAGMA, that means high anion gap metabolic acidosis, bicarbonate should be 6. But instead, as we see in the question, it is 24. Okay, it is 24, but not 6, it is 24 now. So what happens? The fact that this HCO3 is much higher than the calculated or expected, it says that patient is also in metabolic alkalosis. It says patient is also in metabolic alkalosis, which is due to vomiting and loss of HCl loss of HCl. Okay, so this is a case where the values have balanced so perfectly that it seems that there is no problem at all. So you can see the values are so balanced, you cannot see or identify the problem at all. Okay, this is how you approach. So the answer here is mixed metabolic alkalosis and high anion gap metabolic acidosis.